Okay, just a quick review of some of these problems in set number 2 here in chapter 6, lesson 1. And we have problem number 4. The value of an expression such as 3x plus y depends on the number by which we replace the variables. Replacing x and y with the ordered pair 4, 5 for an example gives 3x plus y is equal to 3 times 4 plus 5, which is equal to 12 plus 5, which is 17. So when we don't have an equation, we just have an expression. Note the term that we use there is an expression. If we had an equation, there would have been an equal sign, and we said 3x plus y is equal to something, but we're just simply given an expression. So it can equal whatever x and y is, and we can simply say, well, if x is something, y is something, then this is going to be equal to something. So we're not really limited in any way. We just simply can say what 3x plus y is equal to when we're given values for x and y. And in this case, we were given the value 4 and 5, and we found out that if the ordered pair 4, 5 is used in this expression, then the answer is going to be 17. So if we look now and we read what they want us to do here is they say find the values for the following expressions if x and y are replaced by the ordered pair given. So we're given 4 different expressions, and we simply have to go in and plug those values in as they did in the first one. And I'll just show you the first example. We have 2x plus 5y. Okay, so we have an expression, not an equation, and we're given the ordered pair 5, 1. Okay, so we have 5, 1. That's the ordered pair. Let me put this over here on the side so that I can work out my problem. So for A, we have 5, 1. Okay, which means that the first number 5 is actually for the x value, so I would replace that here with the x, and the 1 would be the y value. And again, just going back, remember it's an ordered pair, x comes before y. Okay, now we would do our math here, and what would we get? Well, we'd get 10, that's 2 times 5 plus 5. So the answer here would be 15, okay? So we found the value, okay, of the following expressions. We're told to find values for expression. Now, it's quite different, and again, I'll go back to, don't get confused, and we're going to build further on. Ultimately, we may say, well, 2x plus 5y is equal to 20. Find the values of x and y to make this true. Now that would be totally different than doing what we did here, because we're being given a value, okay, and we're being asked to say what, or actually the values of x and y, and we're being asked what is this value, okay? And in this case, we actually have the value. We need to know what fits, what would make this true. In this case, anything would be true in the sense that as long as we're doing our math properly, we're simply saying 2x plus 5y is an expression. Plug in any value you want, or in this case, they're giving us a set of values, A, B, C, D, and we need to plug in those values. So that's basically how we do number 4. Now in number 5 it says one of the solutions to the equation, now you see this has changed. This is number 5 and we're seeing an equation 3x plus y equals 17. So now we're given this same equation down here, or expression, but we're turning it into equation by putting the equal sign. So now we're restricted to exactly what this is equal to. This is always going to be equal to this. Now, we know, it says here that, tell whether or not, well, we know that 4, 5 was the value. Okay, so they use 4, 5. Let me just put that over here as an ordered pair. And when we use 4, 5, we know that this is true. And you can see here is the example, 3 times 4 plus 5 is equal to 12. 12 plus 5 is equal to 17. Now, granted, above in the first problem, if you look at number 4, they use the expression 3x plus y. In the second one, they said one of the solutions to the equation 3x plus y is equal to 17. Okay, so now we've limited ourselves to an equation. not just the full-blown expression of whatever it could be, whatever you want it to be. Now, x and y have to be certain numbers, and they have to be certain numbers for this equation to be true. So, the instructions are to tell whether or not each of the following ordered pairs is a solution of the given equation. So if we look now, we're going to have the same expressions are being used, but they're turned into they're being used in equations, and in each case we're given a set of values that we now have to determine whether or not it's true. Okay, now I can see the very first one, 5, 1, we had already done that, and it was true. But if I look at the second one and I see 1, 5, I'm going to say 2 times 1 is 2, 5 times 5 is 25, 2 plus 25 does not equal 15. So that means B is not an answer. Okay, and that's what we have to do with the rest of these problems, is just plug in the values for x and y and determine whether or not these are true for this particular equation. Okay, and in the first, number 4, in the first problems, we're simply given expressions and we're told to plug in the values and tell us, well, what is the value of it? In this one, we're saying that expression is going to always equal something. So what would be the answer if it's only equal to that? So those are 4 and 5. They're fairly similar, but one builds on the other. One's talking about an expression, the other one is now working with equations. And remember, expression is almost like a word, let's just say, in English, and an expression is more like a sentence. It's giving you the full thought. The expression is just a word. It's just like a house, okay? And then when you use an expression, is I live in the house on the hill. Okay, now you're defining that house and you're giving me something that in a sense it equates to. So let's just think of it in those terms when we think of equations versus expressions. Okay?